Okay, so to continue, did you know that every degree measure has an equivalent radian measure? Yes or no? Show a reaction, please. Do you agree? Did you know that? Do you agree that every degree measure has an equivalent radian measure? Why, Maki, ba't kayo? Okay, so I guess you're not familiar, but now let's make everything clear. Yes, that's right. Every degree measure has an equivalent radian measure. And how is that? We just have to use this certain formula for us to convert degree to radian. And this is the formula. Here. So for us to convert radian measure, degree measure to radian measure, all we have to do is to multiply or get the degree. For example, let's use this as 90. Let's use this. So we have 90 degrees. We need to multiply it by pi over 180 radians. Pi. Okay? And we just have to simplify it now. So therefore, this is 90 times pi over 180 rad. All we have to do, of course, this is over 1. 90 and 180, they are exactly divisible. 90 and 180, this becomes 1/2. Can you follow? And then end to end, that becomes pi over 1 times 2, 2 radians. This is the equivalent of 90 degrees in radian measures. Got it? Show a reaction if you understood that process. Okay. Let's have another. Ready? Let's try this. Ready? So we have 40 degrees. Multiply it by pi over 180 radians. It's always like this. This is always the term that we multiply by the degree to change it to radian measures. So therefore, when we simplify this, over 1. So to what number are they divisible? They are divisible by 20. So therefore, this is 2 and this is 9. So when we multiply them, 2 times pi, that becomes 2 pi over 1 times 9, that's 9 radians. That is the radian measure of 40 degrees. Can you follow? Show a reaction if you understood that process. Very good. Oh, what about this? Let's change this. What about this? 97 degrees. Change it to radian measures. Type the answer in the chat box. 97 radian measures. 97 degrees. Change it to radian measures. Type your answer in the chat box, please. Okay. 1. Got it correctly. Oops, kulang ka ng radian. Rad is always the unit of measurement. Dapat meron siyang rad lagi. Okay. There you go, radians. Okay, correct. Linnea is correct. What about the rest? Still waiting for the rest. What is the radian measure of 97 degrees? Some might be having a problem solving this because they cannot find a common factor that will simplify them both. If that's the case, don't problemize it masyado. Kung hindi nyo siya masisimplify, that's it. Don't worry. Okay, type your answer in the chat box, please. Waiting for the rest. Type your answer in the chat box. Okay, chance is correct. Let's wait for the rest. Okay. Wala na. Okay, let's do this. Okay, oops. Okay. Let's have this. Always remember, some of our classmates still wrote the degree symbol in their answers. Remember, the degree symbols are canceled together with their units kasi there's a degree here and there's a degree here. So therefore, the degree symbol is already canceled out. Okay, so what's left will be pi rad. Remember that, ha? When your angle is already in radian measures, there will be no degree symbols anymore. Okay, let's try this. So just write our angle, that is 97 degrees. 97 degrees. Multiply it by pi over 180 radians. Okay? And so look at this. So there's degree symbol there. 97 and 180. There is no common factor that will simplify them both. So therefore, let it be. What will only be canceled here will be the degree symbols. Can you follow? So what's left will be 97 times pi, that's 97 pi, over 1 times 180, that's 180 radians. Can you follow? So 97 degree is expressed as 97 pi over 180 radians. Can you follow? Show a reaction, please, if you understood that process. Got it? And finally, what is the radian measure of 180 degrees? Go. What is the radian measure of 180 degrees? Type your answer in the chat box. Okay. The spelling of pi is P-I, huh? Not P-I-E. Pi, pi, this one, this symbol is spelled as P-I. Don't put E, huh? That's for pie chart only or for pi. The pi symbol is spelled as P-I. Remember that. Okay, good. And always remember, please put your rod or your radian at the end because that serves as your unit of measurement. Okay, that's it. You're correct. Your classmates are correct. Very good. So therefore, all we have to do is to write 180 degrees multiplied by pi over 180 degrees rad. Okay, so canceled, canceled. What's left will be pi rad or pi radian. That's it. Can you follow? Show a reaction if you understood that process. Changing degree to radian. Very good. Let's continue. If we have radian to degree, degree to radian, we also have radian to degree. Baliktad naman. So, radian to degree. And in this case, all we have to do is to use the formula that is the kabaligtaran of the first formula. And that is multiplying our radian measure by pi over 180. Okay, going back to our degree measure, look at it. Degree to radian, you need to multiply your degree by pi over 180. In this case, you need to multiply your radian by 180 over pi. So get the reciprocal of the pi and 180, 180 over pi, and that is for your degree measure. Okay, let's try this. Let's try this original given na lang to verify if they will go back to their original values. We have pi over 2 rad. We also have 2 pi over 9 rad, 2 pi over 9 rad. We also have 97 pi over 180 rad. And we have pi rad. Okay? This time we will be changing them to degree measure. Okay? This is just very simple. So all we have to do is to multiply our pi rad by our radian measure pi over 2. Okay, this time it's okay not to write anymore the rad. Okay, wala nang problema doon. Okay, and then multiply it by 180 over pi. So this time, this is pi over pi, that's just 1. And then 180 divided by 2, that is 90. So what's left here will be 90 degrees. Are we back to our original given? Yes, it's 90. Now, I'll give you a task to do. Go back to you kindly try to convert these three. Of course, they will go back to their positions, but try to learn the process, changing radian to degree. Go. Type your answers in the chat box once you were able to verify that these pi radian measures went back to their original degree measures. Go. Try the process, learn the process. You can just simply look at the previous examples. However, I want you to go back to the process. Go, learn the process. Princess already sent the first one. She was able to already verify the first given, correct? Let's wait for the rest. Okay. Mauricio, may akadwa na Princess. Okay, Jaisal verified the first. Oy, Linnea verified the 3. Okay. Okay, let's now continue. So, let's just copy the radian measure. That's 2 pi over 9 multiplied by 180 over pi. Okay, cancel the pi. And then 9 divided by 180, that's 20. So 2 times 20, that becomes 40 degrees. Correct? Similarly, with 97 pi over 180 multiplied by 180 over pi. So pi is equal to 97 degrees. That's what's left. And finally, the pi rad. Let's see if this will go back to 180 degrees. Pi multiplied by 180 over pi. Of course, what's left is 180 degrees. So that's how we convert radian measures to degrees. Got it? Very good. Show a reaction if you understood that process, please. Let me see. Okay. Explore the emoticons. Very good. Okay. Wow, you're doing good. So that's how we convert them. Okay. Let's now move on. Ready? With the angles in standard position and coterminal angles. This is very easy. Let's move on. Ready? With this one. Okay. Let me just draw a Cartesian plane, the X and Y axis here. I'll draw 2. Okay. And then the vertical, the horizontal, the x-axis. This is also very easy. Marami lang, Pero madaling intindihin yung lesson natin for this week. Okay, let's start the ball rolling. Let me just put the arrows of my Cartesian planes. Okay, so let's now move on with the angles in standard position and co-terminal angles. Ready? When we say angles in standard position, that is when we have the initial side at the positive x-axis. There. It becomes standard. It has standard position if your initial side or the start of your angle is on this side. It. So let that be the initial side of your angle. Okay, I made it red. So let it be initial side. IS meaning initial side. Okay. And then we have here another line. And when we say, if we have our initial side, we must also have the terminal side. The terminal meaning that's the end. That's the end side, the other side of your angle. So if this is the case, let that be our terminal side, TS. And the terminal side can go wherever it wants. It can go in any quadrant. Let's say, for example, in this figure, in our other figure, the terminal side is on the first quadrant, while in this other figure that I'm drawing right now, the other side of the angle is on the third quadrant, and this is the terminal side. Always remember, if they are following this kind of position, this angle is in standard position. Okay? So therefore, if your initial side is on the positive x-axis, that is always in standard position. Okay? Now, what are we learning here? We will not be learning anymore about the other non-standard positions because that's what we learned when we were in geometry. All the other angles presented were all in non-standard position. But in here, always that the initial side is on the positive x-axis. Okay? So show me a reaction if you understood the meaning of the initial side and the terminal side. Let me see. Siyempre, we need to understand muna the terminologies before we move on. But don't worry, this is very easy. Okay, that's it. Thank you. So, let's continue. In here, this angle, that is our angle. And look at the arrow. The arrow always shows direction from your initial side going to your terminal side. Can you follow? So that is the angle formed. On the other figure in here, from your initial side going to your terminal side, that is your angle formed. So always remember, in trigonometry, we always follow a certain position, certain direction with regards our angles. Okay? And these two angles are both in standard positions. Okay? Got it? Now, let's have the coterminal angles. When we say coterminal angles, these are angles that have the same terminal side. Terminal side. So if two angles in standard position have the same terminal side, they are called coterminal angles. Let's look at this. In here, if from the standard position, of course, from the initial side, it's going to the left, para kasi this is the first quadrant, second, third, and the fourth. So the movement really of the angle should be like this. It's counterclockwise. So if that's the case, your sign, the sign of your angle is always positive if you follow that direction for your angle. So let's say, for example, this measures 40 degrees. Is it a positive or a negative? Following the initial side and the terminal side, is it positive 40 or negative 40? Type your answer in the chat box, please. Is it positive or negative? Always remember, if the movement is like this, that is positive. If the movement is the other way around, the counterclockwise, that's negative. Okay? So your classmates are now posting their answers. That's correct. That is positive 40. Okay? Now, let's draw another angle here. What if from here, using the same initial side, this angle goes to this side? Okay, so we now have two coterminal angles. What's the sign of the angle formed by the purple direction? Is it a positive or a negative? Type your answer in the chat box, please. Very good. It's negative. That's correct. Simply because it is following the clockwise direction. Okay. Question. If the green angle measures 40 degrees, what do you think is the measurement of our purple angle? What do you think is the measurement of the purple angle? They are still thinking. I'll give you some hint. Okay, I'll give you a hint. If we have here, by the way, what's the measurement here? If it is perpendicular, what is that angle? What's that angle? What's that angle? If the symbol is square, what's this? That is right angle. That's 90. There are 4 right angles in this one revolution. So if this is 90, this is 90, and this is 90, what's the measurement of one revolution? What's the measurement of one revolution? 360 degrees, correct. This is what we call the one revolution. Okay, now going back to our question a while ago. We have here 40 degrees, positive 40 degrees as one angle. And then we have another coterminal angle here, which is the purple direction. What do you think is the measurement of that? Type your answer in the chat box, please. What's the coterminal of 40? The negative coterminal of 40. The answer is negative 320 degrees. Very good. Is it 320 or negative 320? Is it positive 320 or negative 320? Negative po pala. That's correct. It's negative because your direction is the other way around. Can you follow? Okay. Let's now have another example. Look at this other angle here. So this is still in standard position. So I expect that this measures, this is already 90. This is 90. And this, for example, is 50 degrees. So 90 plus 90 plus 50, 180, or plus 50. That's 0, 8, 9, 10, 30, 230 degrees. Okay. So the first angle, kumbaga, I'm showing you the connection of one another. Ne? So this measures 230 degrees. That's the first angle. What do you think is the measurement of this coterminal angle? Gain. What's the measurement of that purple coterminal angle? Type your answer in the chat box. Type your answer in the chat box. Okay, I want Your classmates to post their answers first. Okay. The answer is, of course. So this is 130 degrees. Positive or negative? Positive or negative? It's negative. Correct, because it is in clockwise position. Can you follow? Okay. What if? So we're done with this. Let's remove this now. And I don't like you anymore. I'm so tired of those negative angles because actually I don't like negative angles. Let's have this. What is the first positive coterminal angle of 40 degrees? What does that mean? Imagine the movement of this angle. I want you to look with me, watch with me in this figure. Look at this. Ready? From my initial side, there's my angle. There's my angle. Look at the direction. And there it is. That is another coterminal angle. But look at the direction. Is it a positive or a negative coterminal angle? Type your answer in the chat box. Is it a positive or a negative coterminal angle? The answer is, your classmates are correct. It's positive because the direction is counterclockwise. That's nice. It's not negative kasi yung movement mo is this direction. Look at it. Oh. There's a direction. Okay? So it's a positive coterminal angle. What do you think is the measurement of that coterminal angle? Type your answer in the chat box, please. What's the measurement of that positive coterminal angle? I want you to imagine it. Kindly imagine it. 360 hanggang 1 revolution lang yon. Okay, ready? This becomes exciting now. So there are different answers sent by your classmates. Most of you are sending 400 degrees. There's 320, there's 360, but mostly 400. Okay, let's take a look at this. Okay, I want you to imagine this. Ready? Same initial side. Tell me the measurement. That's 90, 180, 270, 360. 1 revolution. But if it only ended in that 1 revolution, initial side to initial side, are they coterminal angles? Yes or no? This is just 360 degrees. 1 revolution. Are they coterminal or not? Type your answer in the chat box, please. Are they coterminal or not? Remember, they become coterminal angle if they have the same initial side and the same terminal side. They ended in the same terminal side. Look at this figure. It's only 1 revolution, 360. Are they coterminal or not? Coterminal or not? They should end with the same terminal side. It's not. It's not kasi nasa initial side pa siya. Okay? Now, but we continue. We already have 360 degrees. If we continue pa going to the terminal side, what do you think is the measurement of that? It will not be 360 anymore kasi nag-extend na siya. What's the measurement of that? Of course, we have 360 plus the 40 extension here. The 40 extension. So therefore 360 plus 40, that becomes 400 degrees. Can you follow? Oh, one more. Ready? Ready? I hope you can follow the process. I don't like this na. Level up natin ng konti. Actually, there's a formula here, but I want you to understand the process. Kasi kung formula lang, after a week, you will forget the formula, surely. But if you understand the skill the process of doing it, it's a lot easier to solve. See, I don't have any formula here na ginagamit, pero I can still remember what's the meaning of this. Ready? Game. Ready? Look at this naman. Same initial side. 1 revolution. 2 revolutions. And I ended there. What is the measurement of that coterminal angle? Type your answer in the chat box. Okay. Let's see. Your classmates are now getting the hook of it. Very good. So from this initial side, dalawang beses tayong umikot. So that's 360 plus 360 plus the extension of 40. That becomes 760 degrees. That's the other positive coterminal angle. Got it? Did you get the process? Show a reaction if you understood that process. Very good. So these are two positive coterminal angles of 40 degrees. Can you follow? Okay, let's move on to this one naman. Okay. So I already have this first negative coterminal angle. This is the first negative coterminal angle. Okay? Now, I want you to give me the second negative coterminal angle. Go. Type your answer in the chat box. Give me the second coterminal angle of this figure. Go. Can you imagine it? Okay, I'll help you first with an illustration. Oy, merong mga nagsasend na ng mga sagot nila. Sige. Tuloy. Aha. Tignan natin. Let me remove this now. That's 230. Let's just make it smaller. So this is 230 degrees. Okay. And this is negative 130, of course. That's the first negative coterminal angle. I want you to identify the second negative coterminal angle. How is that? Ready? So we all know that the first negative coterminal angle is negative 130 degrees. Okay? Gusto ko siyang ituloy pa dito. Shh. There. What do you think will I add with 130? What should I add with negative 130 para makuha ko? Yun, exactly. Very good. I need to add one more revolution kasi umikot pa ako ng isang beses. So therefore, negative 130 plus another negative 360. The answer will be negative 490 degrees. That's it. That's the second negative coterminal angle. Got it? Very good. Show me a reaction if you understood that process. Okay, finally, one more. Ready? This time, I'll just give you a statement and give me the answers. Ready? Find the first positive and first negative coterminal angles of 60 degrees. Go. Find the first positive and the first negative coterminal angles of 60. Type your answer in the chat box when you're done. It will help if you will draw it in your paper because you will be able to imagine the movement of these coterminal angles. Okay, your classmates are now sending their answers. Let's keep them going. Okay, and I'm happy you are getting the answers correct. Okay. Uh-huh. Okay. So let's now do this. 60 degrees is somewhere right here. There. Yun. 60 degrees is somewhere over there. Yan. This is the 60 degrees. Yan. So therefore, that is 60. That is our turn, that is our angle. So we need another positive, the first coterminal, and another negative. Okay. So yung 60 is not yet the coterminal. Wala pa siyang coterminal. Ito yung hinahanapan mo ng ka-coterminal. So therefore, if you answered 60 a while ago, OMG, that's wrong because 60 degrees is not yet a coterminal angle of another positive. Kailangan mo yung unang ka-coterminal niya na positive. So therefore, what we need to do is to move from here up to there. That's the first positive coterminal angle. And what's that? 360 plus 60, that is 420 degrees. This is the first positive coterminal angle. Can you follow? And for the first negative naman, this is from the initial side going to that side. So therefore, that's 360 minus 60. That becomes 300 and 300 degrees. And that should be negative. So negative 300 degrees and 420 degrees are the first positive and the first negative coterminal angles of 60 degrees. Can you follow? So this is the first negative. Can you follow? Show a reaction if you understood that process. Very good. And if ever you are having a difficulty learning that skill, you can just use this formula. Theta plus 360K. K stands for the number of positive or number of negative values. Okay? That's it. Ito kasi yung gusto kong tinuturo at pinag-aaralan kasi ito yung skill talaga ng angles rather than just formulas. The formulas, you can solve the value but you can never imagine the movement. But I'm teaching you the movement, the skill itself because that's more important.